Just like Taylor Swift, I'm feeling 22. And 22 to the fourth power is 234,256. Or 234,256. Isn't that weird? No, it's not. It's actually completely normal, so yeah, Anyway, now 234,256 might seem like a large value, but it really is not. Or is it? No, it's not. But in this video, I want to talk about just how high math can get. And I'm talking about in the numerical way, not the plant way. We know that there is no end to our numbers. There are infinite. But infinity, although sounds cool in titles of movies, is not really applicable to us. We don't experience infinity ever, unless you're fighting Gojo. Our entire world has real limits with real values. There's a finite speed in the universe. There's a finite limit to how small things can get. There's even a limit to how high up soda can go. 7 up. So what is the highest numerical value that we can get to, realistically? Well, 7. It also is the amount of days in a week. There's 52 weeks in a year, there are 118 elements on the periodic table of elements, and the moon is about 240,000 miles from the Earth, but these are all still very small values. Okay, so there are 86 billion neurons in our brain, there are 100 billion stars in the Milky Way galaxy, and there are 2 trillion galaxies in the observable universe. If each of these galaxies was $1, then it would take 42 universes to showcase the GDP of the entire world, which is about $84 trillion. That's pretty high. If you ever wanted to know how many ants there are on Earth, well, that's about 10 quadrillion, which is 1 with 16 zeros next to it. There are about 8 quintillion grains of sand on Earth, which is 8 with 18 zeros next to it. Try saying 8 with 18 7 times fast. But even this is minuscule compared to how many stars there are in the observable universe. That comes out to 1 septillion, or 10 to the 24th, which if that sounds like a lot, we can go much higher. There are 10 to the 80 atoms in the observable universe, which is 1 with 80 zeros next to it. At this point, we can't even comprehend how high these values are, but whatever. There are 10 to the 120 possible games of chess, which is so absurdly large that if each game of chess was a single atom in the universe, it would take 10 to the 40 universes to account for every possible game. But chess isn't even the king of the category of board games. That title goes to Go, which is also a strategy-based game and can have a mind-boggling 10 to the 170 possible outcomes. But that's only based on the average moves per game. If we move up to the higher limit of this, then we can go up to 10 to the 761, which is 1 with 761 zeros next to it. But we can go much higher than this with a simple object that's probably in everyone's house, a coin. The odds of you flipping a coin 5,000 times and it landing on tails every time is 1 in 10 to the 1,505. That's 1 with 1,505 zeros next to it. And finally, one Google is not just a search engine, it's a value, which is 10 to the 100, or 1 with 100 zeros next to it. One Googleplex is 10 to the Google, or 10 to the 10 to the 100, which means a Googleplex has 10 to the 100 digits. For perspective, the coin example from before only has 1,505 digits. If you tried to write out every digit in a Googleplex, you wouldn't have enough space to do so in the entire universe. And here's a pretty dumb way to think about this. If every atom in our universe was its own universe with 10 to the 80 atoms in it as well, and every atom in that universe was also its own universe with 10 to the 80 atoms in it as well, and so on and so forth, forever, you would have to go down 1,000 septillion universes and count every atom all the way back to the top, like a pyramid, and even then, this would still be a fraction of a Googleplex. So, yeah.